Before starting these questions, I would highly recommend you have the 7 index laws that we covered earlier in the year. So have them in front of you before approaching these questions. Okay, so let's look at the first one. What we're doing here is we're simplifying algebraic expressions by using index laws. So the first one here, we've got 3a squared b squared to the power of 3 multiplied by 2a to the power of 4 multiplied by b cubed. So the first thing you want to do with all expressions, no matter what you've got, is you want to try and expand your brackets first. Because as soon as you've expanded your brackets, then what you can do is start collecting like terms. So in this first one here, you can see that all of 3a squared b squared is cubed. So let's expand all that out. And the way we do that is by cubing literally every term. So 3 will cube that, a squared will become cubed, and b squared will become cubed. And refer to, I think it's index law number 4, that when you have a power that's being raised to the power of another power, those two multiply. And so 2 will multiply with 3 to make 6. And even on the a term as well, the squared will multiply by 3 to become a to the power of 6. So let's go ahead and rewrite this. The 3 will become cubed. So 3 times 3 times 3, that will be 27. I might just use a lighter stylus here. 27. And now a to the power of 6 multiplied by b to the power of 6 multiplied by 2a to the 4 b to the 3. Okay. So what we can do now is we can start collecting our like terms. So here we've got 27a to the power of 6 multiplied by 2a to the power of 4. So going back to, I think it's one of the first ones, I think it's index law number 1. Whenever you have two terms, so here we have a to the power of 6 and a to the power of 4, the powers add up together. The numbers next to the letters, so the base numbers, they'll multiply just like normal. So here you'll get 54, a to the power of 10. Notice that the 6 and the 4 added together to make 10. Let's keep going. We've just got one more term left, and that'll be b to the power of, and then it'll become 6 add a 3, which is 9. And there's nothing else we can do there, so that's simplifying that expression. All right, let's have a look at number 2. 4m to the power of 6 times n to the 3 times 12m times n to the power of 5, all divided by 6m to the power of 7 times n to the power of 6. All right, so the difference here is that we've now got an algebraic fraction. So we have numerators and a denominator. The idea behind this, or how to approach this question, is that you want to tackle one at a time. So tackle your numerator first and then tackle your denominator, like one at a time. So let's go ahead by writing the numerator first, and we'll do that at the same time as multiplying our like term. So here we've got 4m to the 6, and I've got 12m to the power of 1. That 5 here, this 5 is only being applied to the letter that it sits on. It's not m and n to the power of 5, it's just n to the power of 5. So this m here is just on its own, it's being raised to the power of just 1. That's why there's no numbers there. So combining that with our first 4m to the power of 6 term, we'll get 48 to the power of m to the power of 7, because that really, if we show you with a secret number here, 1, it would just be 6 plus 1, which is 7. That's why we add 1. All right, let's keep going. All right, so 48m to the 7. Now our last term to deal with on the numerator is the n's, and it will be 3 plus 5, which will be 8. All right, so now that that's done, we can now work on our denominator. Let's use a straight edge line for our fraction. There we go. All right, so I've got 6m to the 7, n to the 6. Notice there that our denominator could not be simplified. There was nothing else I could do, so I'm just writing it. Okay, so now we have simplified numerators and simplified denominators. What you want to go ahead and do now is, in most situations here, you're going to be using index law number 2 where you are dividing, where you're using, index law number 2, where you're taking away the denominator from the numerator. So I'll just rewrite it. Index law number 2 goes as follows. I'll write it down below. A to the power of m over a to the power of n equals a to the power of m minus n. And so if we have a look at, well, let's work on the m's here. M to the power of 7 divided by m to the power of 7 equals m to the power of 7 minus 7, which is 0. And anything to the power of 0 is just 1. So essentially what you can do there, you can just put a line through them, because they cancel each other out. N to the power of 8 divided by n to the power of 6 equals n to the power of 8 minus 6, which is 2. And so if we go to simplify this, this here is just going to be n to the power of 2, and 48 divided by 6, well, that's just 8. So we're going to write 8 n squared. All right, last one. Last one's pretty hard. There's just quite a few things that you have to do. It's just a long process. So notice now we're not multiplying these fractions, we're now dividing this fraction. But the secret is that instead of dividing by this fraction, multiply by the reciprocal of the second fraction. So we'll flip it. We'll flip that second fraction. Before we do that though, I would recommend expanding first. Notice that we have brackets in our second fraction. The whole thing is being cubed. Let's expand that bracket and then we'll multiply by the reciprocal. So I'll rewrite this again. 7a squared b to the 4 over 3a6 b7 divided by, now I'll write a fraction line and we'll start expanding everything. So that 3 is cubing everything inside the brackets, the denominator and the numerator. So let's go ahead. It'll become 27 a cubed b cubed. Let's fix that cubed up. All right, over 8 a to the, now remember, when you are multiplying, when you are raising a power by another power, those two multiply, okay? So that's index law number 4. So it'll be 6 times 3, which is 18, times b to the power of 4 times 3 is 12. Now we'll go ahead and rewrite it all over again. Instead, though, we'll multiply by the reciprocal of the second fraction. So that's just flipping it upside down. So 7a squared, b to the 4 over 3a to the 6, b to the 7, multiplied now by 8a to the 18, b to the 12 over 27a cubed, b cubed. Now what we can start doing is, we can start multiplying our numerators together, right, our like terms, and then we can multiply the like terms on our denominators. So let's start doing that, and we'll start with the numerator first. So we've got like terms here, 7a squared multiplied by 8a to the 18. We'll go ahead and start writing this as 56a to the power of 20. Notice that's index law number 1. We are multiplying powers, and so they add together. Times b to the power of 16. All right, so the numerator's done. Let's go ahead and work with the denominator. 3a to the power of 6 times 27a to the power of 3. That'll be 81a to the power of 9. And times b to the power of 10. All right, our numerator and our denominator have been simplified. What you now are going to be looking for is to use index law number 2, and this is index law number 2 again. Remember, we have a fraction, so we're going to try and see if we can simplify our numerator and our denominator. And here you can see I've got a to the 20 divided by a to the 9. That'll be equal to a to the power of 20 take 9, and this will become, so this part here will become a to the power of 11. Okay? So essentially, this crosses out, and this 20 becomes an 11, because it's 20 minus 9. Same thing goes with b to the power of 16 divided by b to the power of 10. It'll become the b to the power of 16 minus 10, and so that will become 6. So all this gets crossed out, this gets crossed out, and that becomes a 6, because 16 take 10 is 6. And it doesn't look like we can simplify 56 over 81. So we'll go ahead and rewrite this as 56 A11 b to the power of 6 all over